Right, A-level maths, tricky circles question. Let's go through it. So you've got a circle C1, centre 3 minus 1, radius of 5. So that's the smaller one here. And then we got a circle, centre 5, 2, radius of 6. Don't worry, I'll draw a bigger diagram in a minute just to make this a bit clearer. Now, part A is to find the greatest distance between the two circles. And part B is to find the perimeter of the combined circles. So this red perimeter going around the outside of the two circles there. Now, apologies because I'm going to be really cheeky, but I'm not going to do part B because part B is actually a question in my mock exam paper. To get this mock exam paper and to get the solutions, you just have to go to my profile and click this link. And then you get taken to this site here. Now, the question part B, you will find that in the AQA paper 1. So you want to go to AQA paper 1, this one here. This is the paper. The solution is down here, so you can get the solutions down there, just if you're interested in that. But let's go through part A. So the idea with this question about finding the greatest distance between the two circles, the greatest distance is going to be the distance or the length that's going through the centres of both of these circles. So the greatest distance is going to be the radius of the first one plus the distance between the two centres and then plus the radius of the second. So going back to our situation, we had our centres at 3 minus 1, 5 and 2. The radius of the first circle was 5. The radius of the second one was 6. So the greatest distance between any 2 points on these two circles is going to be this radius of 5 plus this radius of 6 there to there. And then also we need to add the distance between the two centres. And we can just get the distance between the two centres by using Pythagoras. So you can clearly see we can just use Pythagoras to get that distance. So we're going from an x coordinate of 3 to 5. That base must be 2. And then y coordinates are minus 1 to 2. That must be 3 there. So just doing Pythagoras, that's going to be the square root of 2 squared, 4, and then plus 3 squared, 9. So root 13. So that there must be root 13. And so therefore the greatest distance for this question is going to be 6 plus root 13 plus 5. So 11 plus root 13 with this question there. Now, you could also get questions about the shortest distance between two circles. I mean, in this question here, that's a bit of a stupid question because the shortest distance is just 0, obviously, because they intersect. But I mean, if you did have circles that did not intersect, like circles like this, well, the shortest distance, again, you'd have your centre there, pull in your centre, pull in the centre of this one. So the shortest distance is along this line from the two centres, and the shortest distance is in fact this distance there to this distance there. So to get that, it's again really similar to this. What you would do is you're going to use Pythagoras to get the distance between the two centres. So very similar calculation to what we did here, where you want to do Pythagoras to get this long distance, but you know the radius of this circle. Let's just pretend that's a radius of 5 there. Let's pretend this radius there is 3. So you're going to do Pythagoras to work out the distance between the two centres, and then just get that distance, take away 5, take away 3, you then got this distance in the middle there, because 3 plus this distance plus 5 has to equal the distance between the two centres. Now, I did say I'm not going to go through part B, but I will give you a clue because you are still watching the video, so I want to reward you with a clue. So the clue to get the perimeter of the entire shape, well, what you want to do, you want to realise that this from the centre to this point there is a radius. Let me do this in green. So that radius there was 5 because the radius of the smaller circle was 5, so that's 5 there. The radius of the bigger circle, so this distance from this intersection point to there, is going to be 6, so that there is 6. And then what you can do, again, because we know the distance between the 2 points there was root 13, so we calculated that this distance is root 13. So what you can do now is you can use cosine rule to work out perhaps this angle there, and we'll call that theta. And then you can realise that basically what we've got going on here, we've got congruent triangles. So that triangle that I've created there is congruent to this one because that length there is also 5. That length there is also 6. That length in the middle is root 13. So you know that that angle there is also the same. So that's theta as well. And perhaps you could call this angle there alpha, and that angle alpha, you can work out that angle again using cosine rule. So now you've got the angles here and the angles there. That should help you get the two lengths. So that's my clue. If you do have any questions, just let me know.